Assalamualaikum and very good day to everyone. My name is Nur Azalia bintu Abu Bakar from Razak Faculty of Technology and Informatics, University Technology Malaysia, and I'll be presenting a paper titled Impact Analysis on Disaster Data for Disaster Risk Reduction from Multiple Stakeholder Perspective. This is the research background of our studies. Currently, the process of the disaster risk reduction, DRR, relies heavily on the geospatial information defined, such as topographic map, semantic map, plans, charts, and also the satellite images. So, this preparation and use of geospatial information involve many parties, such as these data custodian, data providers, data users, and also data vendors. And due to the different data format, sizes, and type of both spatial and non-spatial data, this data processing become more complex and time-consuming. Furthermore, there are some supplied data that is lack of specific reasoning behind it. So as a result, the volume of spatial and non-spatial data keep piling up daily without any beneficial utilization. So our research objective is to investigate the impact of disaster-related data of both spatial and non-spatial that can contribute to disaster risk reduction from multiple stakeholders' perspective. In this study, we involve 54 agencies that is related to the disaster risk management in the Selangor state of Malaysia, which consists of the data provider, data custodian, data users, and also the data vendors. This is the scenario of disaster risk management in the Selangor state of Malaysia. Selangor is one of the states in Malaysia with the largest economy in terms of GDP, whereby it contributes to 23.7% to Malaysian GDP. And Selangor initially has this kind of initiative called Smart Disaster Management Program, which is under the Smart Selangor program. Under this Smart Disaster Management Program, there are one unit that are responsible to it, which is Selangor State Disaster Management Unit, whereby this unit are the one who coordinate all the disaster management activities in Selangor, ranging from planning, implementation, and also the monitoring. This is the scope of the SDMU, what they are doing. Monitoring the rainfall, the weather, the geospatial satellite image, and also about the welfare and then the community, everything about it. And this is the daily looks of the SDMU. It is the one-stop 24 hours communication center supported by the latest technology and experts to monitor and report any disaster directly to all the relevant authorities. So, what about the disaster and the big analytics? Since 2014, Zobel and Hansa already attempt to characterize these disasters of the various events, and followed by studies by Emmanuel and Nicholas 2015, they proposed that data analytics can be used in this disaster management, whereby in 2017, Papadopoulos et al. Also suggested that public data can be used for the disaster resilience. And in 2017 also, Masood, Su, and Khalid also suggested that this analysis of supply chain is beneficial in disasters management. And recently, Savary, Novari, and Kadre also suggested that this data analytics has big potential to be utilized in the disaster management. Hence, we continue their studies by proposing our studies to utilize this big data analytic in disaster risk reduction. And firstly, what we want to do is to analyze which data has the impact for this big data analytics before we proceed with the algorithm to do the descriptive, predictive, and also the prescriptive. We want to analyze and identify these data first. Which one has impactful data? This is our research methodology. We use a qualitative approach which is very exploratory since there are lack of these similar studies in the context of Malaysia and Selangor specifically. For the data collection purposes, we conduct this focus group discussion. We have 8 groups, and during this focus group discussion, we conduct this interview based on our design interview protocol, and also we already created this data collection template. So there will be no biases, and the data we gather also consistent in between these 8 groups. And the participants are from 54 disaster-related agencies, whereby we have altogether 110 participants. And our research team also, we have 24 researchers to assist this focus group discussion process. And we also get the assistance from the STMU team, whereby 5 officers really dedicated in assisting us, the research team from UTM, and also to involve with all these 54 agencies that we identified. Okay, for the data analysis, we use Atlas TI as a tool to assist us to analyze these interviews data, and the technique that we use is on the thematic analysis introduced by Brown and Clark 2006. And based on this thematic analysis, we conduct this frequency analysis to know which data that is really relevant and has impact data according to the response by these participants. And this is the finding. Firstly, let me explain about the first finding, which is the disaster-based data. Disaster-based data refers to any main data that related to disaster risk reduction, consists of topographical data sets, soil type, soil administrative map, disaster risk map, and so on. So, we were able to identify 20 impactful data ranging from topographical or GIS data until the satellite images. And this is the base data and the grouping of the team that we found out from the interview with our participants. Second data is the vulnerability data, whereby vulnerability refers to the vulnerability of an individual or a community asset or system to a disaster. So for this vulnerability data, we are able to identify 13 impactful data as per category shown in these blue dots here. Okay, starting from land use data until the soil sample data. And then the third finding is the hazard data. Hazard data refers to the set of data that includes time of disaster that has occurred, including the history of disaster, model that describe the disaster, and also where is the area and intensity of the disaster. So for the hazard data, there are 5 data that is really important and has the impact, and we group it according to the hazard projection data and also the flood hazard map. Flood is the most occurrent disaster that happened in Malaysia. Okay, flood and also the landslide. Okay, and the next data that we identify is the exposure data. Exposure data refers to the situation of the people living in this area. So it's more involved on the infrastructure, the housing area, the agriculture production, data about the physical assets and the resources that located at the disaster risk area. So with that, we are able to identify 5 relevant data that has impact on this exposure data. And then finally is the risk impact data, whereby for the risk impact data, it covers on the purpose of having the continuous quality improvement for the agency. Okay, and then what agency can do on the plannings, on the strategic management, on the improvement later on. So this data refers to the internal usage, whereby how agency can reuse this kind of data, maybe from the reports, from the statistic and so on, and then the impact on the ecology and also the impact on the environment. So altogether we have 4 types of data that is important when we're talking about this impact data. Okay, so as a summary, we're able to identify these disaster-based data, exposure data, hazard data, vulnerability data, and risk impact assessment data as a main theme. And all this main theme has the sub-theme that can be used later when we want to design and extract the exact data to be used when we conduct this disaster risk reduction analytics. So from there, we are able to produce a more accurate and beneficial statistic and dashboard for the use of these multiple stakeholders in disasters risk reduction. Okay, so as for the conclusion and recommendation, we would like to say that our proposed data during the focus group discussion are all important and relevant. Only that we ask the participants to rank it academically and to verify the data that we propose. And we also found out there is strong commitment by all agencies that involved in disaster risk activities in Selangor and Malaysia generally. But then there are some limitations, such as they're having a difficulty in sharing the data and information, either it's partial or non-spatial data, and there's still lack of technical and non-technical expertise in disaster data management, and it falls that since there are lack of expertise, so there are lack of deployment in the latest analytic technology to support this analysis of disaster related data. And we've also found that there is so many unexplored data that can be used to strengthen this DRR activities. So for our recommendation, we would like them to improve the reporting system for disaster related data, not just reliance on the spatial data. They also can utilize on this data-driven analytics approaches. Okay, and this number 2 is to strengthen the multiple stakeholder platform for data sharing and exchange, so everyone can get the benefit from this data analytics and can be shared also among all the agencies in Malaysia. And number 3 is to establish a metadata or multi-hazard or complex disaster risk. This is going to be a future project that's going to be very beneficial and can be replicated to any other domain as well, not just in disaster risk management and also in other aspects. And number 4, we also suggested that this agency should utilize on the big data analytics to support the decision making process in order to produce a more accurate and fast result. And finally, we want to highlight that the science-based, which is the normal topography, the satellite that they're being using currently in disaster management, can be embedded with the data-driven solution, which is when you have this analytics function together. So we hope that with this integration of science-based and data-driven, we can reduce more disaster risk, we can prevent risk, we can strengthen the disaster resilience in this changing climate. So with that, I end my presentation. Thank you so much for everyone who's watching. I open this session for question and answer. Thank you so much.